I got square root of 2 plus 1. This is how I did it, and you might have picked a different one, but you should have came up with the same answer. I chose the 1 minus cosine over sine.
Wait, why is that easier though to do?
Because then your fraction doesn't, you don't have to worry about multiplying by the conjugate, you just have to multiply by 1. So that's why I bolded that one, and I told you that's usually the one you're going to use as much as possible. If you would have chose the other one, you would have had 1 plus cosine on the bottom, which would have meant that you had to multiply by a conjugate versus square root of 2 over 2. I'm guessing that you guys chose the other one, because I heard stuff about the conjugate. Do you see how much easier it is if you would have picked this one? Because if you pick this one, it's 1 minus cosine 3 pi over 4. So we have to rewrite this as 3 pi over 4 divided by 2. That's what tells me it's half angle divided by 2 tells me half. 1 minus cosine 3 pi over 4, sine of 3 pi over 4. You don't have to have that memorized. You get to use that sheet that I handed out to you today, the identity sheet, on the test. So do not lose it. We'll actually add something to it today. Well, cosine 3 pi over 4 is negative square root of 2 over 2. Sine 3 pi over 4 is a positive square root of 2 over 2. Multiply top and bottom by 2. Because I don't like dealing with fractions over fractions. Just get rid of them. That. Questions on that? That. I should just use that all the time. It's like this and like that. And like that enough. All right, questions on the homework? No, there's no questions on the homework. Okay, then we will. I already said there's no. I gave you plenty of time, Luke. You have your hand up.
Yeah.
Okay, David. 29? 29. If you look at your identity sheet, that's sine of x over 1 plus cosine of x, which is your tangent half angle formula. So 29, since this is our half angle formula, it tells you it's going to be tangent of whatever our angle is divided by 2. That's 12 over 2, which simplifies the tangent of 6. 6 isn't on my unit circle. That's as far as I can go with that guy. All right, next. Luke.
31.
31?
But I don't get it.
For this one?
Yeah.
Look at your identity sheet.
Okay.
I don't have my identity sheets right on me, but I'll point to it. The one I just handed to you.
Oh.
There you go.
This one?
This one. Yep. So all of our identities that we need are on here.
Okay.
So we're going to look at, it says sine over 1 plus cosine. Well, sine over 1 plus cosine is right here.
Oh, okay.
So I'm just going to take that x value, which happens to be 12 in that one, and I'm going to replace it there.
I get it.
All right, Luke, what was your question?
31.
31. So 31 was probably the toughest one on that side. It was the whole fact that in order to use 2 times sine of x, cosine of x, you have to just have one angle, and they both have to be the same on each one. So what you were required to do was turn each of those angles into just one angle by doing the subtraction that was given. So this one's pi over 8 minus pi over 2. Create a common denominator. Pi over 2 minus pi over 8, create a common denominator. Pushing them together, I get negative 3 pi over 8 and a positive 3 pi over 8. That's a big no-no. They have to be the exact same angle. They look the same, but one's negative and one's positive. They're going completely different directions. So in order to deal with that, I need to get rid of the negative sign here. Well, either it disappears or I pull it out front. With sine, I pull it out front, so it becomes a negative 2 sine 3 pi over 8, cosine 3 pi over 8, which you can see simplifies down to the negative sign of 2 times 3 pi over 8 from our identities, which equals negative sine 3 pi over 4, which equals negative square root of 2 over 2. Cool?
Yes.
You like that?
Yeah.
That there? That. Okay, who has a question about that? Who's got it? Yeah.
33.
33. Oh, I'm so close to having it up there. 33, we're going to see is cosine squared of an angle minus sine squared of that same angle. If you look at your identity sheet, that's going to be your cosine double angle. Because cosine of 2x equals cosine squared x minus sine squared x. So we just had to go backwards. That is very, very blurry. That is a little clearer. So we just go backwards to the double angle, which means I have 2 times an angle. The angle is pi over 9. That's as far as I can go. Other questions? Yeah. 21. I'm going to do 21 and 13 all together because you might have got those right, but got it right for the wrong reasons. So 13 and 21 are asking the same thing. I just need you to put a positive sign or a negative sign down. So you're 50-50 if you have no idea what you're doing. What's going to tell me whether it's negative or positive is which quadrant the original angle was in. The original angle. Everyone should pay attention to that. It has to be the original angle. Because I know this is 200 degrees, but 200 degrees is not my original angle. This was a tool. This was the half angle formula. My original angle would have been cosine of 200 divided by 2. My original angle would have been 100 degrees for that one. 100 degrees, that's in quadrant 2. So my answer is going to be negative because it's a cosine. And cosine is negative in quadrant 2. For 21, almost all of this is useless. Almost all of it's useless because you already have all the information right here. Tangent of negative pi over 12. You just have to figure out which quadrant negative 5 pi over 12 is in. I just made it positive by adding 2 pi, found out it's in quadrant 4. You could have also put it in degrees. Sometimes it's just easier to put those stuff in degrees. It just makes it a little quicker. And just a little tip about putting things in degrees. Pi equals 180 degrees. Pi is half the circle. So if you just replace pi with 180 degrees, you now have it in degrees. So you could just do 5 times 180 degrees divided by 12. You have it in degrees. All right, so it's just finding the original angle, what quadrant it is in. Next question. That's it? Yes?
Really quickly, what happened to like the negative 1 on 25?
I got rid of it. No, I don't know. I have to look at it.
Like, yeah, the problem with 2 so like 2.5 minus 1. Like, it makes sense for like the cosine of 45 and everything like that. Ends up being radical 2.
What happens to the negative 1? Look at your identity sheet. Look at your identity sheet, and it says that the cosine of 2x equals 2 times the cosine. Let me take a picture of.
Oh, that makes sense. Sorry, never mind.
Yeah, so your identity sheet says that rewrite this as cosine of 2 times an angle. That's what the identity. And I think it's going to be easier now that you have identity sheets that you're not like turning back to this page and trying to remember what it said. Now you can have something that goes side by side. So that being said, that sheet I handed out to you today can be used on the test, so don't lose it. We might add stuff to it along the way. Second thing is, I probably wouldn't, I know I threw a punch because some people like to keep it there. I'd probably keep it a free sheet that you can just stick off to the side that you can pull out rapidly rather than having to turn to it. That's why there's no page number on it either. So those are free to use however you want to. Just make sure you bring it for the test because you can use it on the test. Okay, let's get into today's notes. A little preface to today's notes. These problems don't take this long. We're just going to put some notes along with what we're doing. All right, that's why I took up a whole page. It's just going to be notes, and it's a bunch of just simplifying, so it's not a bunch of hard stuff. It's not a crazy long problem. That being said, I'm going to put a bunch of information in each of these columns. I can't do that up here without writing super, super small. So what I'm going to do is we're going to start out in this column, your very left-hand column. We're going to start writing in there. I'm just going to go to a blank page, and everything I write on here, you're going to put in that column basically straight down. And then when I go to the new page, it will be on the next column, and then the next column. And I'll say that again once I start. So I need to find sine alpha and cosine alpha. We're going to get rid of the tangent alpha. All right, it just adds a little to it that I don't need it added to. So we're going to get rid of the tangent alpha. We're just going to find sine alpha and cosine alpha. They gave me sine of 2 alpha equals negative 8 over 17. So we have sine 2 alpha equals negative 8 over 17. I can't just divide by 2 on both sides. So don't do that. This is not a multiplication. This is not a multiplication. So we need to use identities to solve this. And we're going to solve these the same way every single time. So the first thing I'm going to look at is, you see how 2 alpha is between 180 and 270? Well, that means, let's use something different. That means 2 alpha is in quadrant 3. Two alpha is in quadrant 3 because it's somewhere between 180 and 270. Now we're going to be finding sine alpha. We're going to be finding sine alpha, so I need to know where sine or alpha is, what quadrant alpha is in. Alpha will most likely never be in the same quadrant as 2 alpha because you have one angle and double angle is twice as big as it. So all we have to do to figure out where alpha is just divide everything by 2. So 180 divided by 2, 2 alpha divided by 2 is alpha, 270 divided by 2. So this will give me my alpha. So if I rewrite this, we can rewrite it as 90 degrees is less than alpha is less than 135 degrees. So that right there is going to tell me that alpha is in quadrant 2. And you might say, well, this isn't the entire quadrant 2. It's just 90 to 135. Doesn't matter. If any parts of it in quadrant 2, it's in quadrant 2. So you're basically looking for this 90 degrees to tell you it's in quadrant. It's something bigger than 90 degrees, so it must be quadrant 2. All right, we have to get both of those. We have to know where our double angle is, and we have to know where our single angle is. All right, now we're going to go to this first column. We're in the far left column, right at the top of our far left column. We're going to write cosine of 2 alpha. This is going to be our cosine of 2 alpha column. We are always going to find cosine of 2 alpha first. It's always going to be the first step in this problem. So once again, we're always going to find cosine of 2 alpha first. However, if you look at your homework, your very first problem, they straight up tell you cosine of 2 alpha. If they ever give you cosine of 2 alpha, you can skip everything we're about to do in this whole column. We skip this whole column if they give me cosine of 2 alpha. So I'm going to put a little star here that says basically if cosine of 2 alpha is given, skip this step. Skip this step. So we skip that whole column if they say cosine of 2 alpha equals something. This one does not give us cosine of 2 alpha, so we have to find it. And how we're going to find it is we're going to remember from sine squared plus cosine squared equals 1, I can always say that cosine of x equals the square root of 1 minus sine squared x. But I'm looking for 2 alpha, so I'm going to let x equal 2 alpha just to help me in the problem. So I'm going to let x equal 2 alpha. So that just means that cosine of 2 alpha is going to equal the square root of 1 minus sine squared 2 alpha. But in the very start of the problem, they told me what sine 2 alpha equaled. So just remember that sine of 2 alpha equals, was it negative 8? I don't have it up anymore. Negative 8 over 17. So we're just going to plug that in for our sine value. We're just going to plug that in for our sine value. And I'm going to move to the other side, but you're still going down. You're still writing down. I'm moving over, but you're still going down. So I'm going to go up here, and I'm going to say cosine of 2 alpha equals the square root of 1 minus negative 8 over 17 squared. Quite honestly, this most of the time will be actually your first step. You won't write any of this down because you know what sine alpha is, that you can jump straight to this. So that's what I'm saying. I'm giving you a whole bunch of notes that you probably won't write in your homework. So don't think every problem should be this long every single time. So right now I just took the sine squared plus cosine squared equals 1, and I rewrote cosine equals square root of 1 minus whatever sine I was given. I was giving sine of 2 alpha. And we're going to go ahead and square it. Now we get some rather large numbers, so we're going to skip around just a little bit. I'm just going to skip to what this kind of equals. Well, the square root of 17. The square root of 17 is 289. So to create a common denominator, I'm going to change 1 to be 289 over 289. Minus, and negative 8 squared is a positive 64 over 289. So just remember, I rewrote my 1, so I have a common denominator right off the bat. Well, this is going to equal the square root of 225. For those of us that know our perfect squares, that's a good number. Over 289. The square root of 225 is going to be 15. Over the square root of 289 is going to be 17. Now this is either going to be positive or negative depending on what quadrant we're in. So we'll look at what we're talking about. We're talking about 2 alpha. If we look above 2 alpha, you're just holding your pencil there. 2 alpha is in quadrant 3. Cosine is negative in quadrant 3, so this is going to be a negative 15 over 17. All right, continuing on. So that's my cosine of 2 alpha. I'm done with the cosine of 2 alpha column. That column is done. Now we're going to move to the right to our center column. As soon as you find cosine of 2 alpha, we're going to now find cosine alpha. So our next one, we're going to find cosine alpha. So now we're in the cosine alpha column. So steps, always going to say same. Find cosine 2 alpha, then find cosine alpha, then find sine alpha. That's the order we're going to do these in. All right, so cosine alpha, how we're going to find this? Well, we're going to do a little scratch work right below it. This isn't going to help us, this isn't going to solve it, but we're going to do some scratch work. If I ever have cosine of 2x, I can rewrite that as 2 times the cosine squared of x minus 1. That's my double angle identity. And I'm going to have to use that because this is our conversion from a double angle to just a single angle. Yes?
How can you just divide negative 15, 17 by 2
Why would I divide it by 2?
to find what cosine alpha is?
Like I said, we can never can we divide by 2 because this isn't a multiplication.
But isn't sine 2a equivalent to sine a plus a? Right? I mean alpha, sorry. So why can't we just divide it by 2?
It's definitely not going to work. So cosine 2 alpha equals cosine of alpha plus alpha. You'd have to know what alpha was. I know that cosine 2 alpha equals this. I don't know that 2 alpha equals that. I know that cosine of 2 alpha equals it. Okay, so we have to use this formula. I'm going to go ahead and simplify it because we're solving for cosine alpha. I'm going to solve it for cosine x. So I'd add 1 to both sides, which would give me cosine of 2x plus 1 equals 2 times cosine squared x. I'm going to do 2 steps here. I'm going to divide both sides by 2, which would give me cosine of 2x plus 1 divided by 2. And I would have cosine squared, so I'm going to take the square root of both sides just to get the cosine x alone. So that gives me cosine of a double angle plus 1 over 2, square root it, equals cosine of x. This is something we can write on our identity sheet because it's going to make these problems a lot quicker. We won't have to do this every single time. So you can write this on your identity sheet, which you can then use on the test. Yeah, it'd probably be a good place to put it in the double angles. So I would just write cosine of x equals this, because if I know my cosine double angle, I can just plug in that value. So we should all be writing this on our identity sheet unless we have just a super good memory and we memorized it already. Okay, and just real quick, just for quick reference, our cosine of 2 alpha just equaled that negative 8 over 17. No, it equaled negative 15 over 17. So we're going to take that negative 15 over 17 and we're going to plug it in for the double angle there. So going up to the other side, but you are still in the center column, we're going to know that cosine of alpha is going to equal the square root of negative 15 over 17 plus 1 all over 2. And now all it takes is just simplifying from there. So this is going to equal the square root of negative 15 over 17 plus 1. I guess I'll do all the steps here. Negative 15 over 17 plus 17. Nope, let's not do that. That gets too complicated. I'm just going to multiply the top and bottom by 17. It'll make our life a lot easier. Multiply the top by 17, multiply the denominator by 17. Let's not make our life any harder than it has to be. So that's going to equal the square root of, distributing this would be a negative 15 plus 17 all over 34. Well, negative 15 plus 17 is just 2. So this is going to equal square root of 2 over 34. Simplifying the fraction of 2 and 34, it's just 1 over 17. So this is the square root of 1 over 17. Well, that's the square root of 1, which is just 1. So kind of continuing on, I probably wouldn't show all of these steps, because a lot of this can be done in your head. Would be 1 over square root of 17, which equals the square root of 17 over 17. Now cosine alpha is alpha. Alpha is in quadrant 2, and cosine is negative in quadrant 2, so this is going to be a negative because we are in quadrant 2. Quadrant 2 tells me it is negative. So now that you have this equation written down on your identity sheet, you can go cosine alpha and just skip right to plugging in. So really the only work that you need to show is just this, and a lot of this stuff can be done in your head, so it can be really, really quick. Yes?
So when it became negative radical 17 over 17,
Mm-hmm.
did that negative come in there, or did it come in the step before when we changed it from radical 1 over 17 to this 1 over radical?
So as soon as it's negative, it's been negative its entire life. So that would have been negative, 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 this would have been negative.
Okay.
As soon as it's cosine alpha, since alpha is in quadrant 2, whatever answer is always, it's been negative its entire life. Yeah. Sometimes I just don't write it till the end because sometimes you lose the negative. Because sometimes you put it up here, people tend to lose it along the way, and then they don't double check it because they thought they did it earlier. So I always just put it in the end. All right, so our next thing. Obviously, we found cosine alpha. We're going to go ahead and find sine alpha. And in order to find sine alpha, we just have to go back to the fact that sine of x just equals the square root of 1 minus cosine squared x. And that just came from our sine squared plus cosine squared equals 1. Manipulating it to solve for sine x. All right, so we just need to plug in that cosine x, which is actually our cosine alpha. So sine alpha. Now careful here, because there's an easy way to do this and there's a hard way to do it. Here's the easy way. See how we simplified this? Let's just start this equation really quick. So I'd have the square root of 1 minus something squared. What looks easier to square? This guy, so you have 17 over 17 squared, or this guy where you have 1 squared over square root of 17 squared, which is just 17. Which one probably has nicer numbers? Probably this guy. Probably this guy. So I'm going to go ahead and use the unsimplified one. So what I did to myself is I just kind of put a little arrow saying I'm going to use this one over here. So I can't show it going over, but here's my arrow and wait for it. Wait for it. It's gonna pop out here. There it is. To tell myself I'm just going to use that one because it makes my life a little easier. So it's negative 1 over square root of 17 squared. That's going to equal square root of, I know the square root of 17 is going to be 17, so I'm going to create a common denominator right away. Minus negative 1 squared is a positive 1 over 17. That was a common mistake on the test. People squared this and then they made it positive. Squared first, which makes it positive. We always are going to have a negative sign between something that's squared. All right, so it's 17 over 17 minus 1 over 17, which is going to then equal the square root of 16 over 17. Well, that's just going to equal 4 over the square root of 17. Simplifying that, we're going to get 4 square root of 17 over 17. Alpha is in the second quadrant. Sine is positive in the second quadrant, so it's going to be a positive 4 square root of 17 over 17. Once again, you do not have to write your positive. I just do every time to make sure I did my check. Now we have sine alpha, we have our cosine alpha, and I promise you the homework does not take this long or require that much work. In fact, let me show you my solutions to the first one. So that's my answer to the first one, the top one. Since I can skip the first column, I just have to do 2 columns. I just have to find my cosine alpha and my sine alpha. All right, because we can skip that whole first column. Even the one where I couldn't skip it, it's not that much work. It's just simplifying radicals. All right, let's get through this first identity. Let's get through this first identity. All right, so I have sine 3x. I have sine 3x equals sine x times 3 cosine squared x minus sine squared x. This is going to hold true just like it did last time. Whenever you have something like sine of 2x, sine of 3x, sine of 4x, anything like that, that side gets your main priority. All right, because it's hard to go backwards to fix this. So we're going to break this apart. However, we do not have a triple angle identity. We only have a double angle identity. So just like if I had sine of 2x, remember how we broke that apart into x plus x? We're going to do the same exact thing. We're going to break apart sine of 3x into sine of 2x plus x. I got to write a little small so I can, not so much this direction, it's width, because this can get really long, and then I'll get small again. All right, cosine of 2x plus x. So I can see the starting of a double angle. However, in order to use a double angle, it has to be just sine of 2x. I need to find a way to get rid of that other x. The only way I can do that is using our sum angle identities to break it even further apart. We did them on the last test. It's from the last test. So I'm going to rewrite this as sine of 2x times cosine of x plus cosine of 2x sine of x. All right, so that's just our sine alpha times cosine beta plus cosine alpha sine beta. Now I have double angles. Now I have sine of 2x and I have cosine of 2x. We're going to go ahead and rewrite both of those. So I'm going to rewrite sine of 2x using our double angle identity, which would be 2 times sine x cosine x. And don't forget about that cosine that's still hanging outside there. Not equals, plus. Here is the big problem. If you look at your identity sheets, your double identity sheets for cosine, cosine has 3 possible answers. It has 3 possible answers. So what we're going to do is we're going to look to this other side to tell us which one to pick. In order to look at the other side, I need to simplify it just a little bit. So I'm going to work on the other side just for just a second. I got to make sure I give myself enough room. I'm going to build a wall. I have to add more to that, so we'll build it to there. All right, I'm actually going to distribute the sine x to everything in there just to see how it looks more in a simplified fashion. So we are going to have 3 times sine x cosine squared x minus sine cubed x. So all I did is I took the sine x,
Sine squared x.
sine cubed x, because it'd be sine x times sine squared x. Yeah. I'm just distributing the sine x just to simplify it just a little bit. And then I'm going to take a second and look at this first section I did. And in fact, I'm going to complete that first section. I'm going to actually distribute this cosine to this equation. Remember, this is all multiplication, so it just gets put in there once. So that left-hand side, simplified, would be 2 times sine x cosine squared x. So all I did is I multiplied this cosine x times this, which would give me that. Remember, I'm still missing stuff. Still missing stuff. Notice I have 2 times sine x cosine squared x. Over here I have 3 of them. I have 3 of them. Here I have 2 of them. So in this next section, I must be creating a sine x cosine squared x. Well, that means I need to create a cosine squared. We kind of see that? I have to use this to create a cosine squared. So that limits us to 2 of them. It limits us to the 2 cosine squared minus 1 and the cosine squared sine squared. So now I look at what other information I need. I need this sine cubed. Right now I have sine to the first. So I also need to create a sine squared to get my sine cubed. So that means I need a cosine squared and I need a sine squared. There's only one of them that has both of them in it. So I'm going to rewrite cosine of 2x as the cosine squared x minus sine squared x all times sine of x. Because now when I distribute the sine of x to everything, I'm going to create a sine x cosine squared x. And I'm also going to create a sine x times sine squared x equals sine cubed x. I have 2 of these guys, sine x cosine squared x. I have 1 more of them. Add them together and you have 3 of them. So I have 3 sine x cosine squared x minus sine cubed x. That is equal to the other side, and I am done. So this is the hardest part about these identities, is the one where you have like 3 to choose from. Because you have to try to pick the correct one. You might pick the wrong one, and you have to go back and try another one. But do kind of what I did. Think about what you need. I needed another cosine squared. I needed another sine squared to get me sine cubed. It kind of showed me what I needed to pick in order to solve it. All right, we are not going to do the next one. We'll do it on Monday. So real quick, I still have a minute. Homework. Work on it as best you can. We're going to have time to work on Monday, but we're also going to get more problems on Monday. So I'm not going to check your homework on Monday, primarily because people in the play might not have time to do it. But just be aware, if you don't do any of your homework this weekend, you don't do any of it, you have basically a double assignment on Monday. And I'll check them both on Tuesday. So don't hurt yourself. Try to do as much as you can so you don't have to do it all Monday night. All right, everyone, have a wonderful weekend. Hopefully I see you